Write an equation to represent each situation. Define the variables. We have, there are 2 fewer dogs than cats. So we'll let G represents dogs. And C will be the cats. So if there are 2 fewer dogs than cats, we would take the cats and subtract 2 to get the amount of dogs. Write the remaining 3 equations and define your variables. Here we have 2 graphs, graph A and graph B. We're going to discuss 2 possible situations that could be used to describe graph A and then also graph B. So in graph A, it might be something along the lines of, you started 5 miles from home, and then every 2 minutes, you walk 1 more block. So this axis would represent the minutes, and then this would be the blocks from home. So we started out 5 away from home. 2 minutes later, we're 6 away from home. And then 2 minutes after that, we are 7 blocks away from home. It might represent weeks and savings. Maybe they're counting by hundreds here. So after 3 weeks, they haven't saved any money. But then at 4 weeks, they've started to save $100. At 5 weeks, they've saved $200. At 6 weeks, they've saved $300. Now, these aren't represented by a ratio because they don't go through the origin. But we could also represent these graphs using a table of weeks and savings, or minutes and blocks. And we could still represent them with an equation. Here we see a picture of a window with some pieces of trim on the side and some horizontal trim pieces. Notice that the horizontal trim pieces are wider than the window itself. In problem 1, it says pieces of horizontal trim for windows must be 7 inches longer than the window width. Complete the table to show the horizontal trim lengths for the given window widths. So we have the window width and the trim must be 7 inches longer. So 12 plus 7 is 19. 24 plus 7 is 31. $36 plus 7 is 43. 48 plus 7 is 55. 60 plus 7 is 67. And 72 plus 7 would be 79. B. Define variables in this situation. Identify the independent and dependent variable. We will let W be the window width. And T can be the trim length. The trim length depends on the width of the window. So it is the dependent variable. And the window width is the independent variable. Write an equation to represent the relationship between the horizontal trim length and the window width. Use the variables from part B. The trim length is the window width plus 7. Use the completed table from part A to graph the relationship. Label the axes. So now we're going to plot the points. The 12-inch window was 19 inches of trim. The 24-inch window was 31. The next one was 43. 48-inch window was 55 inches. The 60-inch window was 67. The 72-inch window was 79. And the 84, if we add 7 to 84, that would give us 91. Choose a point from the graph. Let's go with 60, 67. Describe its meaning in this situation. A 60-inch window will require trim that is 67 inches long. If the horizontal trim length is 67 inches, what is the window width? So the trim length was 67. The window width was 60 inches. So here we have those to verify our work. 2. Scott sits in his yard. He sees a snail moving near his foot. The graph shows the snail's distance from Scott after Scott sits down. At what rate is the snail moving? Well, in 1 second, it goes 1 centimeter. So it is moving at a rate of 1 centimeter per second. What is the snail's distance from Scott when Scott sits down? So that would be at 0 seconds. The distance is 10 centimeters. Is the snail moving closer to or farther from Scott? Well, the distance from Scott is going up, so it is moving farther from Scott. The distance is growing, so it's getting farther away from him. Part D asks us to select a point. So I'm going to select the point 515. Describe its meaning in this situation. 5 seconds after Scott sits down, the snail is 15 centimeters from him. Which equation represents the snail's distance from Scott in centimeters after Scott has been sitting for X seconds? Let's go back and look at the table. Here I have, or the graph, 515. Another point here is 212. So if I'm trying to go from the time to the distance, 2 plus 10 is 12, and 5 plus 10 is 15, because when he started, the snail was 10 away from him. So we want B, which says the time plus 10 tells us the centimeters. The equation J equals n plus 5 represents the relationship between Julie's age in years and Noah's age in years. Which table represents the relationship between Julie's age and Noah's age? Well, we're going to start with n, and we're adding 5 to get J. If I add 5, that gives me 10. If I add 5, that gives me 15. And if I add 5 to Noah's age, that gives me 20 for Julie's age. So I'm thinking A is correct, but let's check. Is 2 plus 5 10? No. Is 15 plus 5 10? Also no. If I add 5 to Noah's age, does that give me 10? No, that should be 55, so A is correct. Jada runs 3 fewer miles than her sister Kelly. Kelly runs 3 more miles than her sister Jada. Write an equation to represent the relationship between the number of miles that Jada runs and the number of miles that Kelly runs. Well, there are 2 different possibilities depending on which way you approach it. If Jada runs 3 fewer than Kelly, we could take Kelly's and subtract 3 to get Jada's. If Kelly runs 3 more than Jada, we could take Jada's and add 3 to get Kelly's. Both of these equations represent the same relationship, but neither one of them are going to use a ratio value because we can't multiply Jada's by a number to get Kelly's, or vice versa. In a ratio relationship, we have to be able to multiply to keep the pattern going, but this one is an addition or subtraction pattern. So we have those 2 equations there. And then we have these 2 graphs. Both of these graphs have the same steepness. And they both represent the same relationship. But depending on which person, either Kelly or Jada, that you make the independent variable, determines which graph we would use. So in this graph, you can see that when some person does 0, the other person does 3. Well, Kelly does more than Jada, so that would mean this is Jada who completes 0, and this is Kelly. So this equation is paired up with this graph. But over here, if Kelly does more, we would put Kelly as our independent and Jada as our dependent, which would be this equation. So it's still the same relationship between the 2 sisters. It's just a different approach. Riley sells lemonade at a lemonade stand. The graph shows the relationship between the number of cups of lemonade Riley sells and the profit Riley makes. Explain the relationship between the number of cups of lemonade sold and the profit. I see here that the first point shows up at 8, 0. That would mean she needs to sell 8 cups of lemonade before she even starts to make any money. How do you know that Riley's profit is $0 when she sells 8 cups of lemonade? Because this is the point 8, 0, and the x-axis is labeled cups, and the y-axis is labeled profit. Why do you think that is? Well, maybe she had some expenses where she had to purchase the supplies, and so she has to sell 8 cups before she is paid off her supplies. Write an equation to represent the relationship between the cups of lemonade sold, X, and the profit in dollars. So if we start with the cups, eight minus 8 is 0. 10 minus 8 is 2. So the profit is the number of cups sold minus 8. Is the relationship between the number of cups of lemonade sold and the profit a ratio relationship? No. If we go back to the table, or the graph, you can see there's this point 8, 0, and then there's also 16, 8. In a ratio relationship, you would be able to multiply. But 8 times 2 gives us 16, and 0 times 2 does not give us 8. So these are not equivalent. Values for a ratio. What is Riley's profit when she sells 24 cups of lemonade? Well, if we plugged 24 into our equation, 24 minus 8 would be 16, so she earns $16. How many cups of lemonade does she need to sell to earn a profit of $50? Well, remember, Y is the profit, so we're going to put 50 in the Y's position. To solve this equation, we would add 8 to both sides. So that leaves us with X and 58. So she needs to sell 58 cups. The table shows the relationship between the age of Tara's cat in years and the age of Tara's dog in years. Which equation can be used to determine the age of Tara's dog given the age of Tara's cat? So if we start with the cat's age, 3 plus 2 is 5. Not 1, so it can't be A. 3 minus 2 is 1, so it could be B. 3 times 2 is 6, not 1. 3 times 2 is 6. 6 minus 5 is 1, so it might be D. Let's try another point. Let's look at 5. If I replace the C with 5, 5 minus 2 is 3, so I'm still thinking it might be B. Let's check the next one. If I replace the C with 5, 2 times 5 is 10. 10 minus 5 is 5. So it can't be D. It must be C minus 2. The cat minus 2 is 1. Minus 2 is 3. Minus 2 is 5. Minus 2 is 7. That is the end of lesson 24. I believe we have one more lesson in module 4, and then we're headed on to module 5.